Hello guys, welcome to today's class. In today's class, we'll be discussing parametric function. And in this class, we'll be able to understand what a parametric function is and how to differentiate them. If this is your first time seeing my video, do well to follow through to the end of the class. And if you love the video, do well to like and subscribe to the channel so you get notifications when I upload new videos. And if you've been following my videos and you've not subscribed, do well to subscribe. Now let's come to the concept of parametric function. What is a parametric function? Now let's say you have a function defined as y equal to a function of x. This function can be said to be parametric if we can define a parameter, let's say t, such that y is a function of t and x is also a function of t. Let's break it down a bit and understand the concept better. We'd say that if a function is defined this way, that y is a function of x, we can agree that the function is parametric if we can have another parameter, let's say t or theta or something else, any other parameter or variable, such that we can say that y is a function of that parameter. Let's say y is, let's use is a function of t and x is also, let's define a function g of t. When these conditions are met, then we can now say that this is a parametric function. Now let's look at how parametric functions are differentiated. If I want to differentiate this, if I want to find dy dx, look at what we'll do. First, I will have to find, y is defined as a function of t here, and x is also a function of t. So first I will say, I'll find dy dt, right? And this, if I differentiate this, this is more like h prime of t, right? And if I differentiate x with respect to t, because these two variables are all functions of t. So if I differentiate x with respect to t, this will give me g prime of t. That's the first derivative with respect to t. Now, how do I now get my dy dx? To get my dy dx, what I will now do is to find my dy dx will now be this dy dt times dt dx. So we need to find the inverse of this dt dx. And if the x dt is this, then dt dx will be the inverse of this, right? So dt dx. So this will be dt dx. Now if we cross this out, we'll now find our dy dx. And at the end, dy dt is h prime of t. And dt dx will be the inverse of g prime of t. And if we simplify this, we'll have h prime of t over g prime of t. And this will be our dy dx. And if you look at this, you see that when you find your dy dx for every parametric function, it will be defined with respect to t. It will be defined in terms of t, rather. It will be defined in terms of t. So this up here will be in terms of t, and this here will be in terms of t. That is what we call a parametric function, where when you have a relationship between y and x, you can say that it's parametric when there's a parameter, let's say t, defined, such that y is a function of that t and x is a function of that t. And when you find dy dx, your derivative will be in terms of t. That is what we call a parametric function. Now let's look at some practical examples on parametric function and how we can differentiate them. Now let's look at this practical example here. Let x equal to sine theta, y equal to cos theta, find dy dx. Now this is a parametric function because we can see a parameter theta such that x is a function of theta, y is also a function of theta. But remember, we are asked to find dy dx, and y is a function of x. So that's what we call a parametric function, where y is a function of x, but there's a parameter, in this case theta, such that x is a function of theta and y is a function of theta. And if you have to find dy dx, we'll see that at the end of the day, our derivative dy dx will now be in terms of theta. Okay, so let's differentiate this and see how we differentiate parametric functions. Okay, so our x This is x equal to sine theta, and this is y equal to cos theta. The first thing is to differentiate x with respect to theta and y with respect to theta. So let's differentiate x with respect to theta. So this will be the x the theta. If I differentiate sine theta, I will get cos theta. And then let's come to this. Differentiate y with respect to theta. If I differentiate y with respect to theta, I will have differential of cos theta is a negative sine theta. Okay. Now we've gotten the x the theta, the y the theta. Next, we want to find the y the x. To find the y the x, remember, we'll have, this is the y the x. So look at the setup that will definitely reduce this to the y the x. So find the y the theta, dy the theta, then multiply it against the theta dx, so that the theta can cancel the theta here. So we need to find the theta dx. But what you have here is the s the theta. So how do we find the theta dx? By taking the reciprocal of this, or the inverse of this. So this will be the theta dx. And if we continue with this, we'll have our dy d theta is a negative sine theta times our dx, our d theta dx. The theta dx will be the inverse of cos theta. Okay, and this will give us minus sine theta over cos theta. So we have a negative sine theta cos theta, and remember that sine theta over cos theta is tan theta, so we can simplify this to negative tan theta, and that is our answer. So we see that in this parametric function, we're asked to find the y dx, but the final answer, the y dx, is in terms of that parametric value, or the parameter, which is theta here. And that's how we differentiate parametric function. Now let's look at this second example. Let x equal to alpha t squared and y equal to 2 alpha t. Find the y dx in terms of t. This is also a parametric function because we have x to be defined as a function of t and y to be defined as a function of t. The parameter here is t. And so we are asked to find the y dx in terms of t. So let's go. We have x equal to alpha t squared, and we have y equal to 2 alpha t. The first thing is to find the x dt, and then next we find the y dt, and then after that we now find the y dx. So let's differentiate x with respect to t. Our dx dt would be, now this alpha is a constant, so this will be 2 alpha t. Right, now the next is to differentiate y with respect to t. Our dy dt would be 2 alpha. Okay, now the next thing now is to find our dy dx. Let's see how our dy dx will look like. Our dy dx would be dy dt, then dt dx. Dy dt dot dt dx, such that dt can cancel the t and you return back to the y dx. But if we want to achieve this, from here we have the x dt and not the t dx. So we need to invert this to find the t dx. And so that would be that our dy dx would be, our dy dt is 2 alpha, and then our dt dx is the inverse of this, which is 1 over 2 alpha t. And that means that our dy dx would be 2 alpha over 2 alpha t. And this means that our dy dx, if we simplify this, is 1 upon t. And this is our dy dx.